Dear learners, welcome to this session of marketing research. In our previous session, we discussed that the hypothesis is often considered a tentative and testable statement of the possible relationship between two or more variables. But for a hypothesis to be truly valuable in research, it needs to be operationalized. This means formulating it in a way that allows for empirical testing through data collection. A well-constructed hypothesis include clarity, ensuring everyone understand its intent. It should also be grounded in existing knowledge. Perhaps most importantly, the hypothesis must be testable. This means the variables involved need to be clearly defined and measurable, allowing us to gather data that supports or disproves the proposed relationship stated as hypothesis. We have also discussed some important concepts that are essential for hypothesis testing. This includes the null hypothesis, which serves as the baseline assumption we aim to disprove. Additionally, understanding type 1 and type 2 errors is essential as they represent the potential for rejecting a true null hypothesis for failing to reject a false one. The significance level establishes the threshold for rejecting the null hypothesis based on the p-value, which reflects the probability of observing the obtained results if the null hypothesis were true. The critical region defines the range of outcomes that would lead to rejection of null hypothesis. Furthermore, the confidence level quantifies the certainty associated with our findings. Similarly, various sampling distributions such as normal distribution, chi-square, and t-distributions provide framework for statistical inferences. So it should be clear that there are basically two phases in the testing of hypothesis. The test is designed and the criteria under which the null hypothesis will be rejected are established in the first phase. In the second phase, the developed hypothesis is tested where we have to determine if the null hypothesis can be rejected by using the test on the sample collected. We have already covered the formulation of null and alternative hypothesis and various concepts that help in hypothesis testing. In this session, we will discuss in detail the steps involved in the hypothesis testing process. The learning outcomes of this session are: explain the meaning of hypothesis testing, describe the stages of hypothesis testing process, discuss statistical decisions made in hypothesis testing that are based on concepts such as p-value, type 1 and type 2 errors, and the level of significance. And the final learning outcome is apply hypothesis testing to marketing research problems. Um, we can say that hypothesis testing is a journey of known to unknown in which we test the results of sample data can be generalized for the population of the study or not. We start with a proposed explanation about a relationship between variables, that is hypothesis. Then we gather data from a smaller representative subset of the population, that is a sample. By analyzing this sample data, hypothesis testing helps us determine whether the pattern we see in the sample is likely to be representative of the bigger picture, reflecting the entire population from which the sample was drawn. In simpler terms, it's like taking a water sample from a lake to understand the quality of the entire lake. The sample, though small, can tell us a lot about the larger body of water it represents. By analyzing the sample data, we can assess how well the pattern we observe within the sample reflect the broader population. In essence, it's a way to gauge the generalizability of our findings. Hypothesis testing follows a structured approach. It involves a series of steps like step 1 is state the null and alternative hypothesis. Second step is select an appropriate test statistic. Third is specify the level of significance, that is alpha. Then the fourth step, define the critical region in terms of the test statistic. The fifth step is collect the sample data. Then in the sixth step, analyze the data. Then arrive at statistical conclusion, and final step is discuss the statistical decision in terms of the marketing research problem. Let us discuss these steps one by one. The first step of hypothesis testing is to formulate the null hypothesis and alternative hypothesis. As we have discussed earlier, a null hypothesis is a statement of the status quo. assuming no significant difference or effect. In the absence of compelling evidence to reject the null hypothesis, the current state persists. Conversely, the alternative hypothesis proposes a deviation from the status quo, anticipating a difference or effect. If the data supports the alternative hypothesis, it may necessitate revision to established beliefs or approaches. It is important to note that only one hypothesis, either null or alternative, can be true at a time. We test the null hypothesis, which states that there is no effect or difference between things being compared or tested. If our analysis leads us to reject null hypothesis, it suggests there is likely an effect and supports alternative hypothesis. For a better understanding of setting the null and alternative hypothesis, let's recall the purchase manager's problem that we discussed in our earlier session. The purchase manager has to decide whether to buy soles from a new supplier who has claimed that his soles have higher durability and hardness than those supplied by existing suppliers. Based on past records, the mean durability of soles supplied by existing suppliers is 5 years and the hardness of sole is 20. The purchase manager can test the new supplier's claim about sole hardness by setting up the hypothesis, and it can be symbolically written as h sub 0 such that mu is less than or equal to 20, and alternative hypothesis can be written as h sub 1 such that mu is greater than 20. The purchase manager will reject the null hypothesis only when sample data such as the mean hardness of soles from the new supplier deviates significantly from the established standard. For example, exceeding a hardness of 28 or 30 from existing 20, then the null hypothesis will be rejected. Rejection of null hypothesis leads to the acceptance of the alternative hypothesis and the potential adoption of the new supplier. On the other hand, if null hypothesis is not rejected, it means there is insufficient evidence to support a change and the existing supplier relationship will remain as it is. The step 2 is select an appropriate test statistic. In order to test the null hypothesis, we need to select the right statistical test. This choice depends on how the test statistic is calculated and the kind of distribution it follows. Several factors influence this selection process. The optimal test for a given data set depends on factors such as type of data, is it categorical or continuous. Categorical means distinct groups or classification. For example, gender as male or female, blood groups, O group, A group, B group, etc. So the other type of data is the continuous data, and the data can be continuous where it can take on any value within a range. For example, it can be the height or measurement of weight. The second factor is the level of measurement, how data is measured, which scale we have used. Have we have used the nominal scale or ordinal scale or interval scale or ratio scale. Then the third factor we can consider as a number of variables. As per number of variables, the test can be univariate, bivariate or multivariate. Similarly, we can use the different tests based on the group, one group, or we have to compare the two groups or more than two groups. Then we can consider one factor, that is it a case of relatedness or of difference. So let's see how the scale we use for the data affects the selection of the test statistic. As nominal data utilizes categories for classification, lacking inherent order, meaningful distance between categories are a true 0 point. For example, number on player's t-shirt. The ordinal data establishes order or rank, but the magnitude of difference between categories and the definitive lowest value are not defined. So, example can be the ranking your favorite sports team. Then interval data possesses order and allows for the calculation of meaningful differences in intervals between measurements. But the 0 point is arbitrary. You can take example of measuring temperature in Celsius or Fahrenheit. Ratio data offers the most comprehensive measurement level. It incorporates order, allows for interval comparison and possesses a true 0 point. The example can be measurement of weight or height. We can broadly classify all the statistical tests under parametric versus non-parametric tests based on this level of measurement. Non-parametric tests are not dependent upon the restrictive normality assumption of the population. Additionally, non-parametric tests can be applied to nominal and ordinal scale data. These tests are also referred to as distribution-free statistics. That means do not require the population to be normally distributed. Whereas parametric tests are based on some restrictive assumptions about the population. Generally, these assumptions are with respect to the normality of the population and random selection of samples from the normal population. Additionally, parametric test requires quantitative measurement of the sample data in the form of an interval or ratio scale. So now check, is hypothesis a case of relatedness or of difference? In case of relatedness, check that are you trying to see if there is a connection between two variables. For instance, is there a correlation between exercise frequency and weight loss? In this case, depending on your data types, you might use a Pearson correlation coefficient for continuous data or a Spearman rank correlation coefficient when you use the ordinal data. The second, the difference. Are you trying to see if there is a significant difference between groups on a single variable? An example might be comparing average sleep duration between teenagers and adults. Here, depending on the same size and data normality, you might use an independent sample t-test for normally distributed data or two independent groups test. But in case of the non-parametric data, we can use a Mann-Whitney test or two independent groups. So by considering these factors, we can narrow down the appropriate statistical test for hypothesis testing. For instance, if you are looking for a relationship between two continuous variables, you might use a Pearson correlation coefficient. But if you are comparing two groups on a categorical variable, a chi-square test might be more fitting. Now let's see the step 3, that is the set the level of significance. As we know, whenever we draw inferences about a population based on a smaller sample, there is a risk that an incorrect conclusion will be reached. Two primary types of errors can occur, known as type 1 and type 2 errors. If we wrongly reject null hypothesis when in reality it is true, the error is called a type 1 error. Similarly, when we wrongly accept null hypothesis when it is false, the error is called a type 2 error. In all tests of hypothesis, type 1 error is assumed to be more serious than type 2 error, and so the probability of type 1 error needs to be controlled. This is done by specifying the significance level at which a test is conducted. The significance level, therefore, sets a limit to the possibility of type 1 error, and test procedures are designed so as to get the lowest probability of type 1 error subject to the significance level. The probability of type 1 error is usually represented by the symbol alpha, and the probability of type 2 error is represented by beta. In practice, most tests are conducted at 0.05 value of alpha by convention as well as by convenience. The power of a test is denoted by 1 minus beta, and it reflects the probability to reject a false null hypothesis when it is false and should be rejected. While the beta error is unknown, it connects to the alpha error. An overly strict alpha value like 0.001 inflates beta errors. For balance, alpha is usually set at 0.05, sometimes it is 0.01, other values of alpha are rare. The level of alpha and sample size determines the beta error rate in a study. Increasing the sample size reduces beta for a given alpha value, thereby making the test more powerful. Now let's see the step 4, that is the define the critical region in terms of the test statistic. So here in this step, the researcher tries to establish a critical region. As we discussed, hypothesis testing evaluates whether the observed data provides sufficient evidence to reject a pre-established null hypothesis. The critical area under normal distribution curve helps to decide whether to accept or reject the null hypothesis. To make a decision, researchers need to define a critical value that separates the area under the normal distribution curve into the acceptance and rejection regions. If the computed value of the test statistics falls in the acceptance region, the null hypothesis is accepted. Otherwise, it is rejected. You can also refer this figure 1. The determination of critical value depends on the size of the rejection region, which is directly related to the risk involved in decision making. In simpler terms, the size of the rejection region reflects how certain the researcher wants to be when estimating something about the population parameter based on a sample. Now come to the step 5, that is collect the sample data. During this stage, data are collected through the selection of a representative sample. Two important factors are carefully considered when determining the sample size: the required level of statistical precision by taking into account alpha and beta errors, and other qualitative considerations such as budget constraints and time constraints. We have already discussed sampling methods in details in our earlier sessions. As we discussed, sampling methods can be broadly categorized into two primary groups: probability sampling and non-probability sampling methods. In probability sampling, every element of the population has a known non-zero probability of selection, whereas in non-probability sampling, every element is not included with a known chance if the samples are collected as per convenience. The choice of the sampling method is influenced by the objectives of the business research, availability of financial resources, time constraints, and the nature of the problem to be investigated. Gone through the various types of sampling methods. In case of the non-probability sampling methods, we can use the convenience or accidental sampling, or purposive or judgmental sampling, or quota sampling, or snowball sampling. Whereas in case of the probability sampling, we can use the simple random sampling methods, or systematic sampling, or stratified sampling, or cluster sampling. Now come to the step 6. This stage involves calculating the test statistics based on collected data. That means analyzing the data. The analysis is guided by the specific test being employed and the characteristics of the data itself. For example, the commonly employed normal probability distribution, that is Z statistic, is generally suitable for situations where sample sizes are relatively large. However, when dealing with a smaller sample, typically less than 30 observations, the Z statistics accuracy can become compromised. In such scenario, the T distribution offers a more reliable alternative. This highlights the importance of considering sample size when selecting a test statistic. Beyond sample size, other data characteristics like the type of variable, is it continuous or categorical, and the number of groups being compared, single group, between two groups or three groups, also influence the choice of test statistic. Commonly used options include the Z statistic, T statistic, F statistic, and chi-square statistic. Selecting the most appropriate test statistic ensures a statistically sound analysis and ultimately strengthen the validity of the conclusions drawn from the data. Now, let's see step 7, that is the arrive at statistical conclusion. Through the use of statistical evidence, hypothesis testing ultimately leads to a conclusion regarding the initial claim's validity. The research process started with developing a null hypothesis, which is basically an assumption to be tested. The alternative hypothesis was also framed, which is the opposite of the null hypothesis. This conclusion hinges on a crucial decision to retain or reject the null hypothesis. The basis of this decision is the location of the calculated test statistic within specifically designated acceptance or rejection regions. When testing at 5% significance level, if the observed data exhibits a probability less than 5%, the difference between the sample statistic and the hypothesized population parameter is deemed statistically significant. Consequently, the null hypothesis is rejected in favor of the alternative hypothesis. Conversely, if the observed data probability exceeds 5%, the difference is considered non-significant. In this scenario, the null hypothesis is retained and the alternative hypothesis is rejected. Now, let's see step 8. This is regarding discuss the statistical decision in terms of the marketing research problem. So far, we have discussed that hypothesis testing offers a robust framework for evaluating propositions and informing evidence-based decisions. However, the translation of statistical findings into actionable strategies hinges on the judgment of decision makers who must consider both the statistical significance and the practical implications of the observed effect within the context of organizational goals. Let us take an example to better understand it. Suppose that a marketing manager had decided to go for marketing research to determine the effectiveness of an advertisement campaign on brand awareness. The statistical analysis for the given situation begins by constructing a research question concerning a population parameter such as, does a new marketing campaign influence brand awareness? Based on this research question, null hypothesis can be stated as the marketing campaign has no impact on brand awareness. And alternative hypothesis can be stated as the marketing campaign increases the brand awareness. Researchers gather data often through surveys, control experiments, or existing data sets. Rigorous statistical tests are then employed to analyze this data and calculate a statistic or p-value. Based on the p-value, the null hypothesis is rejected or not rejected at the specified significance level. So, researchers act as translators, transforming complex statistical findings into actionable insight for decision makers. This communication often centers on the calculated p-value and its interpretation. However, statistical significance doesn't automatically equal practical significance. Decision makers now exercise their judgment. He can ask the question as, is the result substantial? They consider the magnitude of the effect observed. Even a statistically significant difference might be too small to be practically relevant. For example, a marginally higher brand awareness due to the campaign might not justify a significant budget allocation. Similarly, he can consider the organizational goals. They evaluate the result in the context of the organizational goals. Does the observed effect, for example, increased brand awareness, align with what the company wants to achieve? For example, it may be the increased sales or market share. Then go for the strategic decisions. Based on this comprehensive assessment, decision makers have range of options. First option, he can implement. If the result is statistically significant, demonstrate a substantial effect, and aligns with organizational goals, the proposed change might be implemented. For example, launching the marketing campaign. The manager can go for further investigation in case where the effect size is unclear or additional context is necessary. Further analysis or research might be warranted before reaching a definitive conclusion, or he may maintain status quo. If the effect is negligible or does not align with organizational goals, the current course of action might be maintained. So, with this, we conclude the session. In this session, we explained the meaning of hypothesis testing, described the stages of hypothesis testing process, discussed the statistical decisions made in hypothesis testing that are based on concepts such as p-value, type 1 and type 2 errors, and the level of significance. We also discussed the hypothesis testing in terms of the marketing research problem. Now, let us check your progress by attempting the following questions. The question 1 is, hypothesis testing is primarily used for option A is generating random ideas, B evaluating propositions and informing decisions, C documenting historical trends, D automating business process. Second question is, when translating statistical findings into action, decision maker should consider option A statistical significance only, B both statistical significance and practical implications, C practical implications only, D the opinions of stakeholders only. Question 3. In the context of organizational goals, statistically significant findings may not be actionable if option A, it is widely accepted by the industry, B, the effect size is very large, C, the cost or effort to implement a change outweigh the potential benefit, and option D is the data collection method was flawed. Question 4. When determining sample size, what two factors crucial for achieving statistical precision? Option A, research budget and time constraint. B, alpha and beta errors. C, data collection method and researcher experience. D, availability of participants and ethical consideration. Question number 5 is, besides statistical precision, what other non-statistical factor might influence sample size? Option A is the clarity of the research question, B, the type of data being collected, C, budgetary limitations, D, the desired level of confidence interval. So with this, we end the session. Thank you. Happy learning.